Okay, so welcome everybody to the first. Welcome everybody to the first round of contributed sessions in this conference. And I'm Hanna Shevchikova from the University of Washington, and I'm going to chair this session on Shiny 1. And there will be a session on Shiny 2 on Friday morning. We have a set of exciting talks lined up, and the rules are the speakers will have 15 minutes for the presentations, and there will be 2 minutes left for questions. And so the first speaker is going to be Olga Mieczwa-Sulima from Epsilon in Warsaw in Poland.
Good morning, everybody. I want to start with asking you a question. What do you think? How popular is Shiny as a tag on Stack Overflow in 2017 among our stats questions?
10,000.
No, like give me the ranking. Like the second, first, 15, 20. Come on, time is ticking. Second. Who else? Third. It's actually third. So this probably means two things. It's a very popular package among our users, but it's not so easy to use it. That's why today I want to share with you lessons learned from the project I did with my team, which involved building a Shiny application that is currently used in production by around 700 logged users. My name is Olga Mieczwa-Sulima, and I'm a data scientist at Epsilon Data Science. I use R every day. I co-organize Warsaw R user meetup. I co-founded the first R Ladies chapter in Poland, in Warsaw, and needless to say, I am also an R doc lady. So let's get started. The project that I will be talking today involved building, a Shiny application that is currently used by 700 logged end users and is supporting their decision making. And at this point, I want to stress that these people have never seen a Shiny app before. They know nothing about R, and to be honest, they don't really care that it's running at the back of the application. The team which was building the app consisted only from the data scientists. We started with 2 PowerPoint slides as a mock-ups, and we had a prototype in Shiny the next day, and we had a working demo after the 2 weeks. But from there, we still had a long way to go. The solution was delivered for BCG, who at the end, we made a very happy client. But before we got there, we had to face 3 major challenges that I will be talking today: user interface, user experience, and scaling. I think majority of us over here have quite high expectations from what the app should look like. This is what we are used to. Companies build whole departments that focus only on making the application looks nice. These are front-end developers, graphic designers, and so on. And to be honest, I think there is the people expect the same from the app, Shiny app. It needs to look good. So let me start with showing you the screen of the Shiny app that, in my opinion, looks quite good. It has a menu on the top, which directs you to the subpage. After clicking it, the content is organized in the containers with colorful labels displaying the content of the container. The tables are nicely styled, containing extra elements like setting a ranking, and in the middle, the content is placed in the reactive cards. This look was achieved thanks to a Shiny semantic package, which is available on CRN and GitHub. And basically what the package does, it allows you to use semantic UI component within your Shiny app. It's an alternative to a currently available Bootstrap in Shiny. And the package is a domain-specific language allowing you to wrap HTML tags. So the package downloads and imports the semantic UI CSS classes. So you can give the semantic UI look to your Shiny and the Markdown reports. It creates what's really important for Shiny users, that it creates the abstraction, enabling you to define Shiny input and Shiny text inputs. It also contains some predefined, more complex elements ready to use as an R function, like multi-selection dropdowns and so on. Using Shiny semantic, we were able to give the app modern look and drop the graphic designer from the process. So at that point, we had nice looking application, but unfortunately it was working quite slow. The first problem we had was filtering, which was filtering to a single element from really huge tables, which was done in the backend of the app. At Epsilon, we are big fans of tidyverse approach, but unfortunately, sometimes it's not enough. So we looked for alternative solutions, and we decided to go for data table indexing, which, after setting a key on the column, allows you to perform a search 25 times faster than using dplyr. And this was a huge improvement for us. Another problem we had was regarding the filtering in the front-end elements. So we had to go for the server-side solution and build our own API for that. So you may ask at this point why we didn't use Shiny selectize for that. Because of the three reasons. We want to have a nicer UI. We wanted to give user more flexibility to search. As you can see in the example, user can search both on the client name and the client ID in the same field, and this list can be further expanded. And last but not least, we wanted to have our custom search algorithm at the back to further optimize the performance. It's actually quite easy to build your own API in R. You can use the register data object from Shiny to set up an API. As in the example, the function register search would return a JSON with the result, and the search query, which is the bolded line, is our own search query algorithm. So using the data table indexing and having our own server-side API improved the performance of the application. However, we faced few challenges regarding rendering the components. So we had part of the output hidden in model windows, which is the top image. This is how the model window looks like. It's subordinate to the main page of the app, and accordions, which is the output that after clicking is expanding like the accordion. And turns out that Shiny is not rendering the hidden output by default. It's an optimization built in Shiny. But what you can do is to change the output options and set suspend when hidden to true, and then Shiny would render the hidden output. But you need to be really careful when doing so, because when you have dozens of hidden elements in your app, they will rend and re-render every time, which will, I guarantee you, slow down your application. and might be never requested by the user. And another challenge we faced regarding the rendering of the component was also related to a Shiny built-in optimization, meaning that the reactive values, they break the reactivity chain if a value doesn't update. And for us it was a problem because we wanted to optimize the front-end elements and only render them when the output changes, but not when the user sets the input. So we use the reactive to keep the state of the reactive value, and in certain situations this was not re-rendering. So we decided to use the reactive trigger to solve this problem. This is a concept introduced by Zhou Cheng, the author of Shiny. It is a simple function that allows you to connect two elements of your Shiny app, and every time the one element changes, this will trigger the change in the other element that is connected to it. And I really like the comparison that Dina Talley made on his blog and described the reactive trigger as a button that triggers the reactivity, but programmatically. I think it really nicely described what this simple and powerful trick does. So having the reactive trigger, we were able to optimize the rendering of the components and avoid unnecessary rendering. So the scale-up. This was a huge challenge because we have a substantial number of users which were using the application, so we had to make sure that the app will be always available. And in order to do that, we used the load balancer, which basically improves the distribution of the workload across the multiple servers. We had multiple instances of the same Shiny app running in the container on the multiple Shiny servers. And we took the authorization to a separate level of our stack. This is how the architecture looks like. So when the user logs in, it's directed by the proxy to a container. It's a Docker container, which is running the Shiny application. And it makes sure that the user is directed to an application with the minimal load, so making sure that app will be available. And this solution is compatible with Amazon EC2, Microsoft Azure, and on-premises. And the authorization can be done by auth0 and HTTP auth. So I hope that I proved that the data science team can efficiently scale production-ready Shiny apps with UI and UX focus quickly and aesthetically. Thank you very much for your attention. Are there any questions? Will someone pass the microphone, or? So the question is, how many users can one server handle? To be honest, it depends, and I think we had around 10 instances of the app running at the back. So more or less it's around 70 users, but it depends. But together with me is my colleague who was involved in building the load balancer solution. So maybe Marek, if you can raise your hand. So maybe Marek afterwards can answer this question in more details to you. Okay. Users, which users? Can you repeat? At the same time. So how many users we manage at the application at the same time? I think at the beginning when we were doing the testing, it was more than 100 users that was using the app at the same time. Yes? As I said, I'm, to be honest, a Shiny developer, and it's quite difficult for me to answer the questions about the infrastructure of the load balancer. So I think my colleague Marek, he's more comfortable to answer you this question. Yes? It's loaded in the memory in the app. Yes? How do we do the updates? So the updates, they actually have to be done manually. So every, and this is currently it's done by the client who is using the app. They have a script, and every time they upload a new data to the server, they need to run the script that will refresh the data and restart the application. And these are the Ansible scripts that does that. Yes? So we had, I think, around up to 10 tables with more than 10 million rows, but I don't know the exact size of the files. Are there any more questions? Okay, thank you very. Can I take this one more question? Yeah, sure. Yes? Well, so we started, so this was the specific request from the client to do it in Shiny, and they were really happy with the result, but when it came to deploying the app and having so many logged users, this was a challenge because, as you all know, Shiny Server Pro is a quite expensive solution to have it for 700 people. So at that time, the client wanted to change to something else. But since we invested so much in this app, we decided that we can make it work and not use the Shiny Server Pro. So that's the answer. Sorry? It's running in the Shiny server, so the Shiny server. There are multiple instances of Shiny servers. So this is not the Pro version. Okay, I'm sorry, I have to finish. I'm happy to talk to you during the break. Thank you very much.